Hello friends, so welcome to the lecture on classification matrix. So what we mean by classification matrix? So these are the measures to evaluate the performance of a classifier. So just consider you are having a classification problem, and what we are doing, we are solving that classification problem using three different algorithms. For example, we are using logistic regression, we are using support vector machine, and we are using, let us say, random forest. So we are having the same problem, but three different algorithms to solve that classification problem. So what will happen? These three algorithms may give you different results. So how to evaluate which one is good? So to evaluate such performances of different classifiers, we use different metrics. So we will learn some of these metrics in this particular lecture. What I will do at the end of this lecture, I will also demonstrate how to evaluate or how to implement these metrics in case of means in Python. So first let me just explain you classification again. So classification is a part of supervised learning. So as you know, there are two things in supervised learning, one is classification and the second one is regression. So here we are talking about classification. So classification is a part of supervised learning, and supervised learning means you are having label data, you are having class information also, through which data inputs can be easily separated into different classes. There may be a binary classification problem or binary classifiers or multiple or multi-class classification. So in case of binary classification, you are having only two classes. For example, positive negative, 0 1, true false, male female, healthy not healthy, COVID positive COVID negative, and so on. But in case of multi-class classification problem, you can have more than two classes. So for example, good, bad, average, or you can have you have to classify a set of players into different games like cricket, hockey, football, and so on. So all these where we are having number of classes more than 2, we say multi-class classification problem. If it is 2, we say binary classification problem. So some of the classification applications, if I talk, these are face recognition, YouTube video categorization, content moderation, medical diagnosis, text classification, speech detection on Twitter, social media analysis. There also you can use classification, you can model social media analysis also as a classification problem, and many more. So how to solve? So as I told you, we are having different tools for solving these classification problems, and some of them are you have already learned one logistic regression in previous lectures. Apart from that, we are having support vector machine, which you will learn at the last week of this course. We are having decision trees, we are having random forest, convolution neural network, recurrent neural network, and many more. Now let us come how to evaluate which one is better for a particular problem. So our first performance evaluation metric is confusion matrix. So it is one of the key concept in classification performance. It is a tabular visualization of the model predictions versus the actual labels. So what we will do? We are having label data. So we will split that label data which we are having from past records or given to us into two parts. One part we will use for training the classifier, whereas the other part we will use to evaluate the performance. So that other part where you are having labeled class, actual class also, the same time we will predict their class using classifier. So we are having actual class information and predicted class information, and based on that we will evaluate the performance. So, in confusion matrix, as I told you, it is a tabular visualization of the model predictions versus the actual class information. So, each row of the confusion matrix represent the instances in an actual class, whereas each column represent the instances in the predicted class. So, for example, to make it more clear, you consider a binary classification problem based on COVID test. So, suppose we are having 1100 samples, those are tested for COVID positive and negative, and out of which 100 found positive and 1000 found negative. Okay. So, these are actual class information using some RT-PCR test or some other test. Okay. So, these are actual class information. Now, what happens, suppose we have taken chest X-ray image of all those patients and we have learned some classification model on chest X-ray, and based on that we are classifying them in positive and negative class. So, suppose whatever classification algorithm you are using on chest X-ray, so out of positive samples 90 are found as positive, and out of the 1000 negative patterns or negative samples 940 are found negative. Okay. So, we are having some misclassification also. So, now we will measure some parameters, one is true positive. So, as you told, we have obtained 90 as positive, total 100, actually there are 100 positive, but our classifier is classifying 90 out of those 100. So, it means my true positive is 90. What is true negative? True negative is 940. True positive means samples those are predicted as positive from the positive data or from the positive one. True negative, the negative predicted samples from the negative one. So, they are 940. Now, false positive. So, false positive means the samples those are in real are negative, but predicted as positive. So, as you see, total we are having 1000 negative samples, out of which only 940 were classified in negative class. So, 60 gone to the positive class. So, those 60 patterns are false positive, and then we are having false negative. So, again the samples those are actually positive, but they have been classified into negative class. So, they are 10, because out of 100 positive 90 are classified in positive class. So, 10 goes to negative 1. Okay. So, now based on these 4 parameters we will make our classification matrix. So, now here you are having actual class information, as I told you, in every row and in every column predicted one, predicted class. So, this number are your true positive, means positive those are classified actually positive and classified into positive class, whereas this is the number those are actually positive, because first row belong to the actual positive one, but classified into negative one, predicted into negative one. This is actually negative and predicted as negative only, and this number is your false positive, means actually these are negative samples, but predicted in positive class. So, such a matrix, here you are having 2 classes. So, it will be a 2 by 2 matrix. If you are having, let us say, n number of classes, you will be having this n by n confusion matrix. So, this matrix is called confusion matrix. Okay. Now, we will see about the classification accuracy. So, the simplest matrix of classification accuracy is defined as the number of correct prediction divided by the total number of predictions multiplied by 100, means in terms of percentage. So, for example, here how many samples we have correctly classified? 90 plus 940 divided by total number of samples are 1100. So, it becomes 1030 divided by 1100 into 100 in terms of percentage. So, it is coming out something equal to 93.6%. So, this is the classification accuracy if we are having this kind of performance. So, we are taking this hypothetical case here. Okay. So, 93.6% is my classification accuracy. However, there are many cases in which classification accuracy is not a good indicator or not a good criteria for performance evaluation. One of such scenario is when your class distribution is imbalanced, means you are having more patterns from a particular class when compared to another class, okay, or one class is more frequent than others. So, in this case, even if you predicted all samples as the most frequent class, you would get a high accuracy rate, which does not make any sense, because your model is not learning anything and it is just predicting everything as the top class. Model is seeing more number of patterns from that class and then predicted everything into that particular class. So, it is not a good performance. So, for example, here suppose whatever example we have seen here, if all the patterns are classified or predicted into negative class. Okay. So, what will happen means what I am saying, all patterns are predicted into negative class. So, what will happen in that case, the classification accuracy will become, so how many correctly classified? A total there are 1100 patterns, all 1100 patterns are classified into negative class. We are having 1000 patterns from that negative class. So, correctly classified 1000 upon 1100 into 100, okay, and this will be bigger than 90%. Okay. So, even though I am not getting at all good performance, everything is classified into negative class, still this classification accuracy is greater than 90%. So, hence classification accuracy is not a good criteria when your class distribution is imbalanced. So, what is the solution? So, we will learn some more classification metrics. One of such metrics is precision. So, what we mean by precision? So, precision gives the fraction of correctly identified as positive out of all predicted as positives. So, it means precision is the ratio of true positive and sum of true positive and false positive. So, in case of earlier example, if we calculate this particular number, so what was my true positive? It was 90, and then so it will become 90 upon 90 plus 60, because 60 is false positive. Okay. So, this number will become 90 upon 150, which is nothing, just 3 upon 5, and this is 0.6. Okay. So, my precision is 0.6 in the example which we are taking. Another parameter is recall. okay, or another metric is recall. So, recall gives the fraction you correctly identified as positive out of all positives. So, sorry, it must be recall. Yeah. So, recall is, as I told you, it is a ratio of true positive and sum of true positive plus false negative. So, it will become 90 and then true positive is 90 plus false negative. So, if you go there, false negative is 10. So, it will become 9 upon 10 and it is nothing just 0.9. So, recall is higher in this case. So, there is always a trade off between precision and recall. If you will try to get high precision, recall will go low and vice versa. So, another good measure based on precision and recall is F1 score. So, it is defined as the harmonic mean of the model's precision and recall. So, it is 2 times precision into recall upon precision plus recall. So, in case of earlier example, 2 into precision is 0.6, recall is 0.9 upon sum of precision and recall, which is nothing just 1.5, and this comes out to be something like 2 times 0.54 upon 1.5. So, it becomes 1.08 upon 1.50. So, this is the F1 score here. And here why we are using harmonic mean? Because it is not sensitive to extremely large values, unlike simple average. So, for example, suppose we have a model with precision of 1 and recall is 0. So, it gives the simple average as 0.5 and an F1 score of 0, because you know, when recall is 0 in numerator, it will multiplied by 0 and everything will be 0. So, if you use simple average okay, arithmetic mean in F1 score calculation, then you can see this scenario. When recall or precision is 0 or very small, F1 score will be close to 0 or 0. So, if one of the parameter is low, the second one no longer matters in the F1 score. The F1 score favors classifiers that have similar precision and recall. Thus, because similar precision and recall, we are having a better balance between them. As I told you, there is a trade off between them. One is low, then other will become high and vice versa. Thus, the F1 score is a better measure to use if you are seeking a balance between precision and recall. Okay. So, we have seen confusion matrix, we have seen precision, we have seen recall, recall is also called sensitivity, and we have seen this F1 score also, which is harmonic mean of precision and recall. Okay. So, now I will give you a brief demonstration how to find out all these measures in Python by taking an example. Okay. So, again we will use Google Colab for this. First I will import the dependency. So, for this again I will use sklearn. So, from sklearn import matrix. Okay. Then what I will do after importing it, I will define two data where I will having some actual classes and predicted classes. So, first let me run it. Now, what I will do? I will define two classes. So, first let me define the actual class. So, let me define y actual and let me take a 1D array for this. So, what I am doing? I am having a set of players, they are having a particular game. So, I am representing their game. So, first player is coming from cricket, second one is coming from hockey. So, C stands for cricket, H stands for hockey, F for football and so on. Then I will be having cricket again, and then the fifth one is again hockey. So, let me define some in this way, then let me take football, let me take cricket again and let me take hockey and hockey. So, what I am having? I am having total 9 players, out of which 3 are having 3 are from cricket, while 4 are coming from hockey and 2 are coming from football. Now, I will define the predicted class. Suppose some data has been obtained from these players and we run some algorithm, classification algorithm, and using that algorithm we are predicting their sports or their class, from which game they are coming, and then it is coming like this. Let us say I am defining as y pred. So, what I am having? Let us say first one is predicted as cricket, second one is again predicted as cricket, third one is predicted as football, fourth one is predicted as hockey, fifth one is again hockey, the sixth one again let us say cricket, seventh one is again let us say cricket, then let us say football and let us say football. Okay. So, these are their predicted classes. So, let me read this data. Yeah, it has been read. Now, I am having these two arrays in which one is having actual class information and the second one is having predicted class information. Now, I will define confusion matrix. So, let us say CM, and CM is nothing. I will import from this matrix class which I have imported from sklearn utility. So, matrix dot classification matrix dot confusion matrix, and here I will pass y actual and then y predicted one. Okay. And then I will put label also. So, labels will be again. So, what games I am having? Cricket, hockey and football. Okay. So, let me try to see and then I will print this confusion matrix. Okay. So, what I am having now, let us see what this confusion matrix is representing. So, here I am having actually 1, 2, 3. So, 3 cricket players. So, from first row is giving you actual class information. So, sum of the first row is 3. Similarly, 4 players actually I am having from hockey, that is sum of second row, and the third row means 2 players are coming from football. So, in that way I am having total 9 player, 3 from cricket, 4 from hockey and 2 from football actual class. So, total there are 4 players, those are classified in cricket. Actually they are 3 actual class, but after prediction we are getting 4. Similarly, I am having 4 players from hockey, but if you see from second column and this diagonal entry in the second row or second column, one hockey player is correctly classified, whereas one of the hockey player is misclassified into cricket. So, and total there are only 2 players, those are classified in hockey. Similarly, one football player is classified in football means correctly, whereas total classification in the football class is 3. So, this is the meaning of classification matrix. Now, let us see precision recall and F1 score. So, the syntax is similar. What I will do, instead of this confusion matrix, I will use classification report. So, let me change it, classification underscore reports, okay, and then rest of the thing will be similar. Yeah, so precision for cricket is 0.5, recall is 0.67, F1 score is 0.57. Total patterns in cricket class is 3. In hockey, precision is 0.5, recall is poor 0.25, F1 score is 0.33, where in football it is 0.33 precision, recall is 0.5 and F1 score is 0.40, and these supports are total number of patterns. So, overall accuracy is 0.44%, overall precision is 0.46, 0.44, 0.47, 0.43 when we talk about macro average, and we talk about weighted average based on the support, it is 0.46, 0.44 and overall F1 score is 0.43. So, in that way you can evaluate the performance of any classifier, and you can evaluate or you can print confusion matrix and classification report from your classifier output. Means for that you need actual class and the predicted class. So, in class we have learned some about some performance evaluation metrics in case of classification problems in machine learning. With this, let me close this lecture. Thank you very much.